Imagine this, about 4,500 years ago, in the middle of the desert, people with ropes, wood, and stone build a perfect geometric mountain, the Great Pyramid. No cranes, no engines, no modern machines. So here's tonight's midnight question. How? Were they slaves? Did they have lost technology? Or is there a simple secret we've been missing? Before we jump in, if you love weird questions that keep your brain awake at night, hit like, subscribe, and turn on the bell so you don't miss the next episode. Alright, now let's answer the real midnight question. How did they actually build the pyramids? First, let's break a famous myth. Slaves built the pyramids. What many researchers argue is more likely, this was a national project. Organized workers, skilled builders, teams, food supply, planning, not a movie scene. A full system running for years. So if it's a system, every step must have a plan. Quarrying, transport, dragging, lifting, placing, finishing. Let's start at the beginning, the stone. The pyramid isn't one giant rock, it's a meticulously assembled mountain of countless stone blocks, each with a specific purpose. This wasn't a monolithic effort, it was a highly specialized, multi-source supply chain operation that would be impressive even today. The builders were masters of logistics, sourcing different types of stone for different parts of the structure. The vast majority of the pyramid, the structural core, was made from millions of limestone blocks quarried right on the Giza Plateau. These were the workhorse stones. Workers would attack the rock face, carving out channels and using wooden wedges soaked in water. As the wood expanded, it would crack the stone free. They'd then roughly shape them using copper chisels and harder dolerite pounding stones. But the pyramid we see today is just the weathered skeleton. In its prime, it was encased in a layer of brilliant, highly polished white limestone. This wasn't local stone. It was a much finer quality material brought from quarries across the Nile, at a place called Tura. These casing stones were cut with incredible precision to fit together seamlessly, creating a smooth, gleaming surface that would have reflected the Egyptian sun like a jewel. And then there was the granite. For the most important structural elements deep inside, the sarcophagus, the walls of the king's chamber, and massive lintels weighing up to 80 tons, they needed something far stronger. They chose the legendary pink granite from Aswan, nearly 900 kilometers to the south. Extracting and transporting these colossal blocks represents one of the project's greatest challenges. So, we have 3 different materials, from 3 different locations, some hundreds of kilometers away. Which brings us to midnight question number 2. How on earth do you move all of that without trucks, trains, or modern cranes? The most logical answer, and the one supported by evidence, is the Nile. The river was ancient Egypt's superhighway. Moving stone on water is infinitely easier than dragging it across hundreds of kilometers of sand. They would have used massive wooden barges, likely timing their heaviest shipments to coincide with the annual inundation when the floodwaters rose, bringing the shoreline and specially dug canals much closer to the construction site itself. It was a brilliant fusion of engineering and environmental planning. Now the stone is near the site, but it still has to move on land. One common idea: wooden sledges. Put the block on a sledge, attach ropes, and teams pull. But there's a problem. Sand is soft, friction is high, the sledge can dig in. And here comes the surprisingly simple trick: water on the sand. Yes, wetting the sand in front of the sledge can reduce sinking and make pulling easier. So part of the pyramid mystery might literally be a splash of water. Dragging the blocks across the desert to the construction site was a monumental achievement in itself, but once they arrived, the Egyptians faced an even more daunting challenge, a problem that has puzzled engineers for centuries. How do you lift 2.5-ton blocks, hundreds of feet, into the air, day after day, for 20 years? Dragging is one thing, but lifting blocks higher and higher, that's the nightmare question. There were no cranes, no engines, only human muscle, rope, and ingenuity. The solution had to be simple, scalable, and brutally effective. The most famous and perhaps most intuitive solution is the ramp. The concept is straightforward: build a rising pathway of earth, rubble, and brick. Each time the pyramid grows a level, the ramp grows too, allowing workers to continue dragging the sledges upward. But this simple idea hides a colossal problem. To maintain a manageable slope, likely no more than 8 to 10%, a single, straight ramp reaching the top of the Great Pyramid would have to be over a mile long. The ramp itself would have contained more material than the pyramid it was built to serve. It's a logistical paradox. So, that leads to a crucial clarification. True, if it's one straight ramp only. But who says it had to be? Archaeologists and engineers have proposed a whole family of ramp theories. There are zigzagging ramps, which switch back and forth up one face of the pyramid. There are spiral ramps, wrapping around the entire structure like a corkscrew. And one of the most intriguing ideas is the internal ramp, a hidden corkscrew tunnel built the pyramid itself, which would have been filled in as the builders worked their way up. Each design has its own trade-offs. A zigzag ramp saves on length, but turning a multi-ton block on a tight corner platform would be incredibly difficult and dangerous. A spiral ramp solves the length issue, but it would obscure the pyramid's corners and faces, making it impossible for surveyors to maintain the structure's precise geometric accuracy as it rose. The internal ramp elegantly solves these problems, but direct archaeological evidence for it remains elusive. And here's the key that unlocks the puzzle: they might not have used just one method the whole time. Many experts now believe the answer lies in a hybrid system. Perhaps a wider, straight ramp was used for the lower, broader levels of the pyramid, where the bulk of the stone was placed. Then, as the pyramid narrowed, the builders could have switched to a more efficient spiral or zigzag ramp for the upper courses. Different stages, different solutions. Ramps got the blocks most of the way there, but for the final placement, another ancient tool was essential: the lever. Using wooden levers, small teams could make precise adjustments, nudging and lifting the massive stones into their final resting place with astonishing accuracy. It wasn't one magic bullet, but a dynamic, evolving strategy. People look at the pyramid and ask, how are the corners so sharp, the angles so consistent, the alignment so accurate? The answer isn't magic, it's skill, measurement, and experience. Rope-based measuring systems observing the sun and stars, learning from earlier pyramid experiments, and improving over time. So it wasn't a one-time lucky guess, it was engineering that evolved. There's also a bold theory. Maybe some blocks weren't cut and hauled. Maybe some were made on site from a limestone mixture, like a primitive cast stone. This is debated and not the main view, but it's important because it reminds us the answer doesn't have to be either impossible or magic. There can be many practical ideas, some surprisingly simple. Midnight question: how many workers did it take? Not necessarily millions at once. Think of it like a giant production machine with departments: quarry teams, river transport teams, dragging teams, ramp and placement teams, rope and carpentry specialists, managers and food supply. A huge operation, each part feeding the next. So, we arrive at the end of our journey, not with a single magical answer, but with something far more impressive. The Great Pyramid wasn't built with one secret trick. It was a symphony of ingenuity, a complex system where every part had to work in perfect harmony. It was a masterpiece of project management. Think about it. The process began hundreds of kilometers away, in the quarries of Aswan. Teams of skilled workers, using simple copper and stone tools, painstakingly extracted colossal granite blocks. These weren't just random stones, they were cut to specification, destined for a precise location in the structure. Then came the logistical ballet. The Nile, ancient Egypt's lifeline, became a superhighway. Barges, laden with tons of stone, navigated the river, timed perfectly with the annual flood to bring their cargo as close to the Giza Plateau as possible. This wasn't luck. It was a planned, seasonal operation integrated into the very rhythm of their world. Once on land, another set of brilliant, practical solutions took over. We saw the power of simple physics, sledges, ropes, and the game-changing realization that a little water on sand could slash the required manpower. It's a testament to observation and experimentation. And then, the vertical challenge. The debate over ramps continues, but the most likely answer is all of them. A combination of a massive straight ramp for the lower, heavier courses, perhaps transitioning to a more efficient spiral or internal ramp as the pyramid grew taller. All the while, smaller teams used levers and brute force for the final, precise placement of each block, accurate to within millimeters. So instead of asking, what's the one secret, the better question is, how did they coordinate all of this so perfectly? How did they manage a workforce of tens of thousands, quarrying, transporting, lifting, and aligning 2.3 million blocks over 2 decades? That is the real marvel. The genius wasn't in a single invention, it was in the system. The meticulous planning, the resource management, the sheer organizational power to make all these moving parts, from the quarry to the capstone, function as one. That coordination, that is the true secret and the most profound legacy of the pyramid builders. Now I want to hear from you. After seeing all the pieces of the puzzle, What aspect of this incredible undertaking shocked you the most? Was it the sheer scale of the logistics, moving stones from Aswan, the simple genius of the water-on-sand trick, or the idea that this was a meticulously organized national project, not the product of slave labor we see in movies? Let me know in the comments. And here's a thought experiment for you. If you were the architect, the Imhotep of your own Great Pyramid, which ramp theory would you bet on? The massive straight ramp, the winding spiral, or the controversial internal ramp? There's no single right answer, which is what makes it so fascinating.